Assalamu alaikum. Following the last video from the series of Physics 9702, in which we had solved some past paper questions from particle physics. In this video, we are going to solve some past paper questions from DC circuits and electricity while emphasizing on the key points in the marking scheme as well. In the very first question from October-November 23, they have asked you to state Ohm's law and they've said state, right? But the very basic mistake I found in your test paper was you just quoted this equation V equals IR and you said that Ohm's law says that voltage is the product of current and voltage. That is not an acceptable statement. You have to write proper statement mentioning the condition, right? Like in this case, you'd say that as per Ohm's law, current passing through a conductor is directly proportional to the potential difference across it is directly proportional to the potential difference across the conductor given that the temperature of conductor remains constant. And why was this condition mentioned? Because with the change in temperature, the resistance of a conductor changes, and the change in resistance would eventually lead to the different change in current with the change in voltage. So in this question, the one mark was assigned for the proportionality relation and the other mark was assigned for mentioning the condition for constant temperature. Then they say that a battery of electromotive force 6.2 volt and a negligible internal resistance is connected in a circuit to a uniform resistance wire, that is this one, a voltmeter and resistor and a switch as shown in the figure. Now, the resistance wire has a resistance of 18 ohm, length 0.94 meter and cross-sectional area this. The slider S is positioned halfway along the length of the wire. Calculate the resistivity of material of resistance wire. We have to calculate the resistivity of the wire. Resistance of the wire is given to be this. Don't go with the resistance of a resistor even if they had provided you with this. इस केस में तो खैर प्रोवाइड ही नहीं ना किया, बट क्योंकि आपको वायर की रेजिस्टिविटी चाहिए तो आप सिर्फ उस वायर की रेजिस्टेंस रखोगे, नॉट एनी अदर रेजिस्टेंस, नॉट द टोटल रेजिस्टेंस ऑफ योर सर्किट. The length of wire is given to be 0.94 meters and the area is given to be 7.2 10 raised to the power minus 8. Now you have to find resistivity. The very common mistake that you had made was खुद ही ये formula दिख रहा है, it's RL over A. That was not the case. The actual formula was R is equals to raw L over A, which you had to rewrite to make resistivity the subject of your equation. That is what you had to write. Now the resistivity आपने calculate करनी है in the unit of ohms into meter. एंड इसके लिए ज़रूरी है कि आप रेजिस्टेंस को ओम्स में रखो विच इज़ ऑलरेडी इन, एंड आप एरिया और लेंथ को मीटर्स के टर्म्स में रखो इंस्टेड ऑफ राइटिंग इन सेंटीमीटर्स. दे अगेन हैड ऑलरेडी प्रोवाइडेड अस विद मीटर, सो इस क्वेश्चन में कन्वर्जन की कोई ज़रूरत मुझे नहीं पड़ी. रेजिस्टिविटी इज रेजिस्टेंस इनटू लेंथ, सॉरी, resistance into area and then over length. This would give us final resistivity in ohms into meter. And this, if I'm not wrong, turns out to be 1.2 exponent minus 6 ohms into meter. Then they say that the switch is open Now state the reading on voltmeter. Like this switch right here is not connected so far, it is open. And when we say that this switch is open, that means we are saying that this resistor is not connected in the circuit अभी तक. इस वक्त आपसे कह रहे हैं कि बताएं वोल्ट मीटर पर रीडिंग क्या आ रही होगी. अब वोल्ट मीटर मुझे कौन सी एग्जैक्ट रीडिंग प्रोवाइड कर रहा होगा. वोल्ट मीटर मुझे यहाँ से यहाँ तक इस वायर की जो लेंथ है इससे एसोसिएटेड जो रेजिस्टेंस है वो प्रोवाइड कर रहा होगा, राइट. उस रेजिस्टेंस के अक्रॉस जो पोटेंशियल ड्रॉप आ रहा है वो प्रोवाइड कर रहा होगा. एंड they ऑलरेडी मेंशन कि अभी ये जो पॉइंटर है ये एग्जैक्टली हाफ ऑफ द वायर लेंथ पर प्लेस किया गया है. क्योंकि आपने इस वायर के अक्रॉस 6.2 का पोटेंशियल अप्लाई किया था तो इसका मतलब है अक्रॉस दिस एंटायर वायर 6.2 का ड्रॉप आया होगा. एंड क्योंकि वायर की लेंथ भी यूनिफॉर्म है, इसका एरिया भी यूनिफॉर्म है एंड इट इज थ्रू आउट मेड अप ऑफ द सेम मटीरियल, सो इसकी रेजिस्टिविटी, इसकी रेजिस्टेंस एग्जैक्ट हाफ होगी यहाँ पर, नॉट रेजिस्टिविटी, राइट. सो अगर टोटल वोल्टेज 6.2 है तो यहाँ पर पॉइंटर रखने पर एग्जैक्ट हाफ वोल्टेज that is 3.1 volt drop होगा and that drop will be reflected in this voltmeter since it is connected in parallel. So जब ये आपसे कह रहे हैं कि जब हम इस स्विच को ओपन रखते हैं और स्लाइडर को हमने बिल्कुल सेंटर में प्लेस किया हुआ है तो इस वक्त वोल्टमीटर क्या रीडिंग देगा. द रीडिंग वुड बी 3.1 volts. देन अब ये कह रहे हैं कि अब आपने उस स्विच को क्लोज कर दिया है. अब आप बताएं कि whether there is going to be an increase, decrease or there is going to be no change in current or voltmeter की रीडिंग. पहले आपके सर्किट में इस वायर की रेजिस्टेंस थी. अब आपने इससे पैरेलल में एक और रेजिस्टेंस अपने सर्किट में इंट्रोड्यूस करवा दी है. Just recall the parallel combination of resistors. What did we use to study? We used to study that जब भी आप रेजिस्टर को पैरेलल में इंट्रोड्यूस करवाते हो, इंट्रोड्यूसिंग रेजिस्टर्स इन पैरेलल, आपके सर्किट की जो इक्विवेलेंट रेजिस्टेंस है वो डिक्रीज हो जाती है. आर टोटल डिक्रीजेस. जब आपके सर्किट की टोटल रेजिस्टेंस डिक्रीज हो गई बट आपने अपने सर्किट को जो ईएमएफ प्रोवाइड किया है that remains the same, या जो आपने वोल्टेज प्रोवाइड किया है that remains the same, so this only suggests that current would increase. So the current in the battery would increase and the reading on voltmeter would decrease. Then the switch remains closed, यानी वो जो fixed resistor था it remains connected to the circuit. The slider is moved along the resistance wire so that the voltmeter reading is 3.1. यानी जब पहले स्लाइडर बिल्कुल सेंटर में था और रीडिंग 3.1 आ रही थी, फिर जैसे ही हमने इस रेजिस्टर को अपने सर्किट में कनेक्ट किया तो अभी हमने कंक्लूड किया कि वोल्ट मीटर पे जो यहाँ पर सेंटर में स्लाइडर रखने पर जो वैल्यू आ रही थी अब वो कम हो गई, यानी वो 3.1 से कम हो गई होगी. अभी आपसे कह रहे हैं कि अगर मैं उस वोल्टेज को इंक्रीज करवा के दोबारा 3.1 पर लाना चाहता हूँ तो आप मुझे बताएं कि मुझे इस पॉइंटर को टूवर्ड्स राइट मूव करवाना चाहिए या टूवर्ड्स लेफ्ट मूव करवाना चाहिए. आपको पता है इस वक्त वोल्टेज कम आ रहा है, right? And this voltage represents the potential drop between this region, pointer और उससे left side के दरमियान जो भी length of wire है इससे associated resistance की वजह से there is going to be some voltage drop. So अगर ये voltage drop कम है इसका मतलब है इस वक्त कम resistance है. So you need to increase the resistance ताकि ज़्यादा से ज़्यादा potential drop आए. And resistance बढ़ाने के लिए because हमें पता है resistance is directly proportional to the length of wire. तो मुझे वायर की length from this point बढ़ानी पड़ेगी. In other words, मुझे इस pointer को towards right इस slider को कहीं move करवाना पड़ेगा, but not at this point. And that is why even if you see the might scheme, it says the pointer placed anywhere between S and the fixed point towards right, but not at this exact point. यहाँ पर दरमियान में कहीं पे भी you can mention the pointer and the value would be greater than the previous value and we say that it is equal to 3.1. So you place a cross there. Then they are saying the circuit in B is altered, like they've made some changes to the circuit by changing the battery for one of a different EMF. यानी पहले 6.2 volts की थी, अब किसी और value का battery हमने assign कर दी है. The student records the following data for the resistance wire. The current in the wire is given, the mean drift, speed of charge carriers is given, and the number density of charge carrier is already given. They are asking you to determine the charge of charge carrier in the wire. Charge nikalna. But they provided us with current, right? This is current, this is velocity, and this is number density. So starting with current, we'll end at charge. Balki, let's do this. Let's start with charge. Charge is the product of current and time. Current is already given. Time is not mentioned here. On a second thought, instead of deriving the equation all again, what we can do is we can directly go with the equation of current, which is this one, where this Q is the charge, V is the drift velocity, A is the area, and this N is the number density of charge carrier, right? So we'll rewrite this equation so that this Q becomes the subject of our equation. Current is given to be 0.93. Area, did they provide us with the area? Yes, they did. 7.2 exponent minus 8. So it's 7.2 exponent minus 8. Then we have number density, which is 9.0 exponent 28. And then we have velocity, which is 1.3 exponent minus 3. You put these all values in your calculator and you'll get your final answer as 1.1 exponent minus 19 coulomb, since this is charge. Now, in the last part, they are saying that with reference to the value of Q, explain why the data recorded by the student cannot be correct. And it is very obvious. The final answer here is 1.1 exponent minus 19. And in all the questions we had been solving from the particle physics as well, and generally too, we know that the fundamental charge is the charge on electron, right? It is 1.6 exponent minus 19. So charge cannot be less than 1.6 exponent minus 19. It is always going to be in integer multiple of this basic value. Like it would be 2 times 1.6 exponent minus 19, 3 times, 4 times, 5 times, or at least 1.6 exponent minus 19. So that is what we are going to mention here, that the value of Q is less than the fundamental value of elementary charge, that is 1.6 exponent minus 19 coulomb. That's it. That's all you have to write here. Then in the very next question, they are saying that sketch the graph for IV characteristic of a filament lamp. We had agreed कि या तो आपको उसकी शेप पता हो तो वो आप जल्दी से बता दें, या there is a chance कि उसमें आपको गलती लग जाए depending on if the examiner has switched x and y axis की labeling. So whenever they are asking you to sketch a graph, always pay attention on what is given on y axis and what is given on x axis, and try to identify what does the slope of this graph represents. Now, the slope of graph is what is given on y over what is given on x. On y-axis, we have current. On x-axis, we have voltage. Now, using Ohm's law, V equals IR. So, I over V, which is this, should equal 1 over R. This makes me conclude that the slope of this graph is inverse of resistance. यानी जब मैं ये शो करना चाहूँ कि रेजिस्टेंस बढ़ रही है तो मुझे ग्राफ के स्लोप को डिक्रीज करवा देना है, एंड जब मैं ये शो करना चाहूँ कि इस फिलामेंट लैम्प की रेजिस्टेंस कम हो रही है तो मैंने ग्राफ के स्लोप को इंक्रीज करवा देना है that eventually would reflect कि resistance कम हो गई। ठीक, ये तो कुछ प्री requisites थे जो हमने establish कर लिए। अब before sketching the graph here, एक जो मुझे दूसरी बात पता होनी चाहिए, that is the characteristic of filament lamp. We had discussed while discussing Ohm's law that there are two types of conductors. We have ohmic materials and non-ohmic materials. Ohmic are the ones which obey Ohm's law, in which voltage is directly proportional, in which the current is directly proportional to voltage, and the resistance of the material does not change, right? So, unlike those conductors, filament lamp is a non-ohmic material. Its resistance changes, and so does the resistance of diode. But जब हम पढ़ रहे थे इन्हें और थर्मिस्टर को, तभी हमने एक पॉइंट एस्टेब्लिश किया था कि फिलामेंट लैम्प की रेजिस्टेंस ना कि सिर्फ ये कि वो कांस्टेंट नहीं रहती, वो चेंज होती है। उसका चेंज कैसा होता है? फिलामेंट लैम्प की रेजिस्टेंस विद द इंक्रीज ऑफ वोल्टेज इंक्रीज हो जाती है। Now coming back to the points we had discussed here, जब मैं ये बताना चाह रही हूँ कि ये एक ऐसा कंपोनेंट है जिसकी रेजिस्टेंस वोल्टेज इंक्रीज होने से इंक्रीज होती है, तो मैं अपने ग्राफ के टर्म्स में उसके स्लोप को ग्रेजुअली डिक्रीज करके बताऊंगी कि इसकी रेजिस्टेंस इंक्रीज हो रही है। एंड द सेम गोज इन दी opposite direction as well. आप polarity change कर दें, the same trend would be observed. Start में for a certain interval it acts as an ohmic material because graph ka slope is almost constant, and then with the increase in voltage current is still increasing. So those of you who has written that with the increase of voltage its current starts to decrease, no, that can never be the case. With the increase in voltage current continues to increase, but the increase in current is starts to स्लो डाउन। यानी पहले अगर वोल्टेज 2 वोल्ट बढ़ाने पे 1 एम्पेयर का इंक्रीज आ रहा था करंट में, तो अब 2 वोल्ट बढ़ाने पे 1 का नहीं, लेट्स से 0.6 एम्पेयर का इंक्रीज आ रहा है, राइट? सो फॉर योर अंडरस्टैंडिंग, increasing voltage increases current, but this increasing current eventually increases the temperature of filament lamp. And as the temperature of filament lamp increases, its resistance also increases, right? And this increase in resistance is reflected by decrease in slope, because we had agreed that the slope represents inverse of resistance. That is exactly what you have to write here. पहले part में they asked you to sketch the graph, and यहाँ पे भी they have mentioned 2 marks. 1 mark is if a student can clearly identify that the curve, that the trend should be a curve, it should not be a straight line, and it should exceed in both the quadrants, first quadrant and third quadrant. And the second mark is assigned if the trend shows clearly that the slope decreases with the increase in voltage. पहले इन्होंने कहा कि आप ये मुझे sketch करके बता दें, and then in the very next part they are asking you to explain the shape of the graph, and जिसमें you are supposed to write this, that initially the voltage and current are almost proportional, but with the increase in voltage the increase in current starts to slow down, and hence the slope of the graph starts to decrease. Then a conducting wire has a length 5.8 meters. It has a cross-sectional area 3.4 exponent minus 8 meters square, and the resistivity is given to be 5.6 exponent minus 8. You have to find the resistance. There couldn't have been a simpler question than this one. R is equals to rho L over A. No need of conversion because the length is in meters, the area is in meters square, and the resistance is in ohms into meters. So yes, the meter remains consistent, and यहाँ पर ohm है, so of course the final answer is going to be in ohms. And you put these values in your calculator, you'd get 9.55, which you can round it off to 9.6. Then in the very next question, In the very next part, it says the resistor of resistance R is placed in a circuit with a cell of negligible internal resistance, two switches S1 and S2, a second resistor of resistance 2R, and three ammeters X, Y, and Z. They are connected in this circuit as shown. And now they are saying that there's when you keep the S1 open and you close S2, then the ammeter X gives you the value of 1.0 ampere. That is when S1 is open and S2 is closed. इसकी बात कर रहे हैं. अब इस केस में वो आपसे कह रहे हैं आप इस पूरे टेबल को कंप्लीट करो. So let's first do it for the case that has been mentioned. इस टाइम पे ये आपसे कह रहे हैं, see, the current has single path to move. Of course, there is a junction, but क्योंकि this path is no longer available for the current to flow because S1 is open, the current has only one path to flow. Coming back all the way here and then back to the battery, right? So मुझे बता दिया ammeter X जो करंट की वैल्यू आपको दे रहा है that is 1, and इस डायग्राम से मुझे समझ में आ गया कि सर्किट में इस वक्त एक सिंगल लूप ही है, so सेम करंट पास होगा पूरे सर्किट से बिकॉज इट इज अ सीरीज कॉम्बिनेशन, पैरेलल वाला पार्ट तो वर्क ही नहीं कर रहा. So whatever was the current measured by ammeter X, same current would pass through the switch, same current would pass through this resistor of value 2R, and the same current would be reflected in the ammeter Z and throughout the loop. So yes, ammeter Z would also reflect a current of 1.0. Oh, sorry. 1.0. And what would be the value of current in Y? Since the Y is placed in series combination with a switch that is open, इस path से कोई current नहीं pass हो रहा, so the ammeter here should give you 0. This gives us 0. Now let's move on to the next combination. This time we have switch S1 closed and then S2 open. Now this time current has this path to follow. This path is not possible. It goes here, here, passing through this resistor, the ammeter Y, and then back to the battery. This makes me conclude current didn't go for this path because the path was open. So इस path में जो ammeter लगा हुआ है, it would give us 0 current. The value of Z this time is going to be 0. And it is also very evident from this diagram that from this figure that whatever was the current passing through X, the same current is passing through Y in this case because एक single loop ही आपके circuit में. लेकिन what mistake most of you had made was आपने खुद ही से assume कर लिया कि this is also going to be 1.0 and so this is also going to be 1.0. Though your idea that both X and Y in this specific case are going to give you the same value, it is correct, but the same value is not 1. It cannot be 1. Why? जब पहले आपके सर्किट में 2R का रेजिस्टर लगा हुआ था उस टाइम पे आपके सर्किट से करंट पास हो रहा था. हाउ इज इट पॉसिबल कि अब आपके सर्किट की रेजिस्टेंस पहले के मुकाबले में हाफ हो गई है, क्योंकि पहले अगर 2R था तो अब आपके सर्किट में R रेजिस्टर लगा हुआ है. तो अगर आपके सर्किट की रेजिस्टेंस हाफ हो गई है तो डोंट यू थिंक जब ईएमएफ कांस्टेंट है तो सर्किट से पास होने वाला करंट डबल हो जाना चाहिए, because V is equals to IR. If V remains constant and R half हो गया है, so in order to keep this V constant, I must double. So अगर पहले I की वैल्यू 5 एम्पेयर होती तो अब इस केस में 10 एम्पेयर लिखते आप. पहले अगर वो 3 एम्पेयर होती तो you would have written 6 amperes this time. But क्योंकि पहले it was 1 ampere, so now you are supposed to write 2 amperes and this is going to remain same for these two. Then अभी तक तो हमारे पास कोई एक पाथ एट अ टाइम क्लोज हो रहा था एंड दूसरा ओपन रह रहा था. right? Now they have provided us with the fourth combination in which they are saying that now both the switches are closed and therefore current is passing through both the loops. अब आप बताएं वैल्यू क्या होनी चाहिए. So this path is also closed and this path is also closed. Yani when the current comes here, ammeter X gives you a reading. Then this right here is a junction and current gets, I wouldn't say divided because it does not have to be in equal parts. The current gets distributed. A certain portion of current goes towards this path S1 and the remaining goes towards S2. Now, according to Kirchhoff's law for current, that is the first law, current entering a junction, which is the value in X, should always equal the current leaving the junction. Current is leaving here, current is leaving here. जो यहाँ पर current it would be reflected in this ammeter and जो यहाँ पर current गया it would be reflected in this ammeter. So following Kirchhoff's rule, current entering a junction should equal current leaving the junction. Yani whatever was the reading in the ammeter X, एमीटर y और z की रीडिंग को जब आप ऐड करो तो आंसर x के बराबर ही आना चाहिए. एक बात मेरे जहन में ये आ गई. अब आप लोगों ने क्या किया है, a few of you have done this. आपने कहा x is going to be 3 and y and z both of them are going to be 1.5. While your answer is correct in one sense and examiner ने इस पे भी 1 मार्क असाइन किया है कि कम से कम बच्चे को ये पता है कि पैरेलल में जो है करंट ऐड करेंगे तो वो आपके पास सोर्स का करंट बन जाएगा. उस हिसाब से यू आर गेटिंग 1 मार्क हियर बिकॉज 1.5 plus 1.5 gives you 3. But you would be penalized for one oversight here. Why? Again, I'd quote the same point here. अगर एक पाथ की रेजिस्टेंस R है and दूसरे पाथ की रेजिस्टेंस उसके मुकाबले में डबल है, why do you think equal current would go from both the paths? The greater current would follow the path which has smaller resistance. जिस पाथ की रेजिस्टेंस डबल है वहां से एग्जैक्टली हाफ करंट पास होगा. अगर इस पाथ की रेजिस्टेंस 10 टाइम्स ज्यादा होती तो इसके मुकाबले में यहां से करंट 10 टाइम्स ज्यादा पास होता. सो कंसिडरिंग दिस प्रिंसिपल इन योर माइंड, यहां से लेट्स से करंट पास हो रहा है 2 एम्पेयर्स. तो इस पाथ से फ्रॉम द स्विच S2 द करंट शुड पास 1 एम्पेयर बिकॉज इसकी रेजिस्टेंस डबल थी इसीलिए यहां से पास होने वाला करंट हो गया हाफ. अगर फ्रॉम द पाथ S1 द पासिंग करंट वाज 5 एम्पेयर तो S2 से कितना करंट पास होता है एग्जैक्टली हाफ व्हिच इज 2.5 ampere. So now it is totally up to you. You can go with any combination while keeping two things to your mind. First, the sum of both these values should give us whichever value we have written here. And ये जो दो values हैं, they cannot be any random value. Whichever is the value written for this ammeter, this should be the exact double. So I can write x would be let's say 12, y would be 8 and z would be 4. See, इसके मुकाबले में this is double. Yes, first condition पूरी हो गई and मैं इन दोनों को ऐड करूं तो क्या मेरे पास ये वैल्यू बन रही है? Yes, ये भी satisfied है. इसके अलावा मैं ये भी लिख सकती थी कि यहाँ पर करंट है 3.0 एंड यहाँ पर करंट है 1.0. इसके मुकाबले में यहाँ पर एग्जैक्ट डबल है which is 2. See, this is half of this value and जब मैं इन दोनों को ऐड करूंगी तो I will get this value. So if you'd see the mark scheme, this would also mention the answer in the same regard कि वैल्यू कुछ भी हो सकती है बस वो ये दो कंडीशंस फॉलो करें एंड अगर वो ये दो कंडीशंस फॉलो कर रही है तो द आंसर इज एक्सेप्टेबल. Now moving towards another question here, we have to state Kirchhoff's second law. Second law was voltage color, right? जिसमें you cannot just mention the voltage is equals to EMF or the potential drop is equal to EMF. You have to mention that the sum of EMFs in a closed loop should equal the sum of potential differences in the same loop. 1 mark for mentioning this sum in both aspects and the other mark for mentioning closed loop. Now, they are saying a battery has electromotive force EMF 4 volt and internal resistance of 0.35 ohm. The battery is connected to a uniform resistance wire XY and a fixed resistor of resistance R as shown in this figure. Wire XY has resistance 0.90 and the potential drop across this wire is 1.8. You have to find the current passing through the wire. V equals IR as per Ohm's law, right? So I should equal V over R. If you have to find the current passing through the wire, you have to mention potential drop across the wire divided by resistance of the wire. That not doing this was the most common mistake you had made. If you have to find the current through the wire, why would you place the resistance of this internal resistance? No, you have to place the resistance of wire, right? And why would you place the voltage supplied by the battery? No, you have to find the current passing through the wire. You have to place the potential drop or the voltage drop across the wire, which they said is 1.8. So current through the wire should equal potential drop across wire, which is 1.8 over the resistance of wire, which they have provided is 0.90. You divide these two, you'd get 2.0, and this is the current passing through the wire. Now, we are saying the number of free electrons that pass a point in the battery in time 45 seconds. We have to find number of free electrons. We cannot directly find free electrons, but yes, since we already know the current, using current and time, we can find the total charge passing in 45 seconds. And once we know the total charge passing, मुझे पता है charge on one electron क्या है, मैं divide करके देख लूंगी कि इस total charge में कितने electron का charge बन रहा है. So starting with I is Q over T, Q that is total charge would be the product of current and time. Current we have calculated was 2.0 and time was 45 seconds. No need for conversion. Final answer was 90 coulomb, but that was the charge. We did not have to find the charge. We had to find the number of free electrons. We know that charge on one electron is 1.6 exponent minus 19, right? Equation आप कैसे बना सकते हो? Total charge is equivalent to n number of electrons, right? So if we have to find how many electrons, we can rewrite this equation where Q is whichever value the charge was calculated to be, and E is the fundamental charge, the elementary charge, that is the charge on electron, which is 1.6 exponent minus 9. So you divide these two values, 90 over 1.6 exponent minus 19 gives us 5.6 exponent 20. And I'm surprised one student had calculated an answer which was 0.25. How is it possible that 0.25 electron is passing in 45 seconds? The answer has to be a huge value, and that is what it is. Now they are asking you to calculate the value of resistance R, and this R is this internal, not internal resistance, this is this external resistance. Now मुझे इस R की वैल्यू फाइंड आउट करनी है. अभी तक आई नो V is equals to IR को यूज करते हुए आई वुड हैव सेड कि मैं अगर रेजिस्टेंस ऑफ एक्सटर्नल रेजिस्टर निकालना चाहती हूँ तो मैं वोल्टेज ड्रॉप अक्रॉस एक्सटर्नल रेजिस्टर को डिवाइड कर दूं करंट पासिंग थ्रू एक्सटर्नल रेजिस्टर से। Why we know that, क्योंकि ये सीरीज में लगा हुआ है पूरा कनेक्शन, तो जो करंट बैटरी से पास हो रहा था which we calculated वायर से पास होने वाला was 2.0, वही सेम करंट इस रेजिस्टर से भी पास होगा। So this is established कि this is going to be 2.0. The problem we have is इन्होंने हमें नहीं बताया कि इस फिक्स रेजिस्टर के अक्रॉस पोटेंशियल ड्रॉप कितना आएगा। तो या तो मैं अपनी इस प्रॉब्लम को दो पार्ट्स में डिवाइड करूं, पहले मैं फाइंड आउट करूं कि इस रेजिस्टर के अक्रॉस कितना पोटेंशियल आया, फिर उसको यूज करते हुए मैं एक्सटर्नल रेजिस्टेंस फाइंड आउट कर लूं, या मैं ये दोनों काम एक सिंगल स्टेप में ही कर लूं यूजिंग किरचॉफ वोल्टेज रूल, राइट, which says the sum of EMFs should equal the sum of PDs. How many EMFs are there? The only source is this one. So EMF की जगह we are going to write 4.0. The sum of potential drops. इस पूरे लूप में कहाँ potential drop हो रहा है? A certain potential would drop across this internal resistor V small r, because internal resistance को we usually represent with small r. Certain potential would drop across this external resistor. Let's represent it with V subscript capital R. And कुछ voltage इस wire के across भी drop कर रहा है ना, because this wire also has some resistance. So अब या तो मैं वी आर अलग से फाइंड आउट करूं और फिर उसे इस फॉर्मूला में प्लेस करके आर फाइंड आउट कर लूं, या व्हाट एल्स आई कैन डू इज आई कैन डायरेक्टली प्रेजेंट द वैल्यू हियर. Voltage across internal resistor would be the product of current passing through internal resistor times the resistance of internal resistor. And likewise, the voltage drop across external resistor is going to be the product of current passing through the external resistor, which is going to be the same because ये सब series में लगे हुए हैं. No need to change the symbol, times the resistance of this external resistor, plus the voltage drop across this external wire. इस external wire के लिए भी मैं ऐसे ही लिखती, current passing through the external wire times the resistance of external wire. And ये दोनों values x y तो हमें already given था 0.90 and I भी हम calculate कर चुके थे, तो या तो मैं ऐसे ही लिख लेती, या what else I can do is मुझे already पता है कि इस वायर के अक्रॉस 1.8 वोल्ट ड्रॉप हुआ था ना, सो मैं डायरेक्टली 1.8 लिख लेती हूँ. एंड देन current was 2.0, internal resistance they've given is 0.35, current was 2.0, external resistance we have to calculate, and this is 1.8. This is the equation. Everything is known, only this R is unknown. So you just rewrite your equation, which I'm doing here. Do not mind the mess here. I just wanted to do the working right next to the figure instead of having to scroll back and down again and again. So 4.0, इसे यहाँ पर रखें. We'll shift the other values to the left side. This becomes minus 1.8, then it becomes minus 2 into 0.35, 0.7. This gives you 2 times R, and you divide it with 2 to get the value of R. And your answer to this R would be 0.75 ohms. Now we have another part here. It says a cell of EMF to 1.2 volt is connected to the circuit. That is shown in the figure B. The connection P is moved along the wire XY. The galvanometer reading is 0 when the distance XP is 0.30 meter. Now you have to remember the concept that we discussed for potentiometer and potential divider, the concept of null point, right? And we had agreed that the galvanometer gives null point whenever जो भी voltage यहाँ पर है, it becomes equal to the potential drop जो इस fixed point और उस pointer के दरमियान की length of wire की जो resistance है उसकी वजह से उसके across potential drop आ रहा है. So what we have to do is, they are saying कि pointer को हमने along the wire move करवाया and galvanometer ने एक point पर आकर मुझे deflection 0 दे दी. अब आप मुझे बताएं इस वायर की टोटल लेंथ क्या है. जब P point पर आकर इसने zero deflection दे दी है. So we are going to compare the potentials what we studied as per the potential dividers, right? The voltage of the entire length of wire XY would be proportional to the length of wire, and then the voltage across this region XP would be proportional to the length of this region XP. Or in other terms, हम कहते थे कि the ratio of voltages should equal to the ratio of lengths. So XY is the entire wire, and पिछले part में they said कि entire wire के across जो potential drop it is 1.4, and now VXP यानी potential drop between point X and P. क्योंकि इन्होंने कह दिया है कि इस कंडीशन में गैल्वानोमीटर नल पॉइंट दे रहा है यानी जीरो डिफ्लेक्शन दे रहा है, सो दिस मेक्स मी कंक्लूड कि इस पोजीशन में जो पोटेंशियल ड्रॉप है XP के दरमियान दिस इज एग्जैक्टली इक्वल टू द पोटेंशियल ड्रॉप जो यहाँ पर सेल का है, which is 1.2. Now the length of entire wire XY, that is what we have to calculate, and the length of the point XP, it is given to be 0.30. So we place 0.30. Now you rewrite this equation, and 1.8 over 1.2 into 0.3, it gives you 0.45 meters. Then they are saying that the fixed resistor is now replaced by a different fixed resistor जिसकी resistance की value greater है. State and explain the change, if any, that must be made to the position of P on the wire so that galvanometer's reading is 0. अभी तक galvanometer एक certain length which we had calculated 0.45 meters थी, जिस पर ये दे रहा था zero deflection. जब आपने एक certain value R का resistor लगाया हुआ था, अभी आपसे कह रहे हैं इसी सर्किट में जो आपने रेजिस्टर लगाया हुआ है फिक्स रेजिस्टर आपने चेंज करके किसी ग्रेटर वैल्यू का फिक्स रेजिस्टर आपने लगा दिया. नाउ कंसिडरिंग कि आपने अपने सर्किट में सीरीज में जो रेजिस्टर लगाया हुआ था आपने उसकी वैल्यू बढ़ा दी, दिस वुड मीन कि आपके सर्किट में जो पोटेंशियल ड्रॉप आ रहा था अक्रॉस दिस रेजिस्टर वो इंक्रीज हो गया. एंड किरचॉफ वोल्टेज रूल सेज कि ईएमएफ तो आपने बढ़ाया नहीं, वो तो अभी भी 4 है. तो अगर किसी एक कंपोनेंट के अक्रॉस पोटेंशियल ड्रॉप बढ़ गया है तो दूसरे कंपोनेंट के अक्रॉस पोटेंशियल ड्रॉप कम हो गया होगा. This internal resistor has fixed resistor, this also has fixed resistor. The potential drop across this wire would have decreased because R के अक्रॉस पोटेंशियल ड्रॉप बढ़ गया है तो इस वायर के अक्रॉस पोटेंशियल ड्रॉप कम हो गया होगा. यानी अगर पहले पॉइंटर P पर रखने पे जो पोटेंशियल है वो 1.2 वोल्ट आ रहा था एंड दोनों बराबर होने की वजह से गैल्वानोमीटर नल पॉइंट दे रहा था, तो अब ये पोटेंशियल इसी सेम पॉइंट पर 0.45 मीटर्स पर would be less than 1.2. let's say 0.9 वोल्ट आ रहा होगा. And in order for me to ensure कि गैल्वानोमीटर दोबारा जीरो डिफ्लेक्शन दे, गैल्वानोमीटर तब जीरो डिफ्लेक्शन देगा जब यहाँ वाला पोटेंशियल यहाँ आ जाए. यानी जब ये जो 0.9 वोल्ट का पोटेंशियल इस वक्त यहाँ आ रहा होगा, इसको इंक्रीज करवाकर मुझे 1.2 पर लेकर जाना है. And in order for the potential drop to increase, we have to ensure that the resistance between the point X and the point P increases, which is only possible if we increase the length between X and P because resistance is directly proportional to the length of wire, and which would mean कि मुझे इस pointer को यहाँ कहीं पर लेकर आना पड़ेगा, that is towards right मुझे लेकर आना पड़ेगा. And that is how you are going to answer this question. आपसे कहा है स्टेट करें कि कहाँ लेकर जाना है एंड फिर आप एक्सप्लेन करें. तो स्टेट में तो आप मेंशन कर दें कि द पॉइंटर will be moved towards right and then explanation में you can write that increasing R increases the potential drop across R. Following Kirchhoff voltage rule, the potential drop across the wire XY and hence across the region XP would decrease, and hence the pointer will be moved towards right to increase the potential to 1.2. I hope it made sense to you. Unlike particle physics, electricity and DC circuits के questions would look um, they'd look like a mess पहली बार देखने में, but it is not as difficult as they present it to be. So make sure that you pay attention to the command word, you pay attention to the series and parallel combinations, the jargon, what the examiner is asking for you, and you'd inshallah be good to go. Till our next video. Allah Hafiz.